You know, it's funny, we can predict eclipses down to the exact second now, but they still have this really ancient, almost mysterious feeling about them, don't they?
They absolutely do. There's a certain awe there.
We all kind of get the basic science, right? Sun, moon, earth, they line up, shadows get cast. Pretty straightforward.
Simple geometry on the surface.
But today, we want to dig a bit deeper than just the geometry. We're looking at something that's always felt a bit uncanny to me. This idea that a total solar eclipse is so visually perfect. Is that just, I don't know, a fluke, a cosmic coincidence, or maybe something else?
It's a great question, and it definitely hooks you. We know the mechanics, like you said, solar eclipse.
Yeah.
Moon passes between sun and earth, blocks the light.
Right.
Lunar eclipse.
Right.
Earth gets in the middle, casts its shadow on the moon. Predictable orbital stuff.
Yeah.
But you nailed it. It's the precision of that total solar eclipse that gets people thinking, really contemplating.
Okay, let's really get into that precision because it's wild. The sun is, what, about 400 times wider than the moon?
Roughly, yes.
But the moon is also, conveniently, about 400 times closer to us than the sun is.
On average, that's the ratio.
And that ratio, well, it seems like a massive coincidence, doesn't it? That's what lets the moon just perfectly cover the sun during totality.
It is quite something.
It really makes you pause and wonder, is it just pure chance? Some random outcome of how things formed? Or is there more to it?
It is mathematically, let's say, improbable. Or at least it feels improbable when you first encounter it.
Yeah.
That such a neat ratio would just happen.
Right.
Now, astrophysics gives us solid models for planetary formation, orbital evolution, all that. It explains how we likely got here.
Sure, the standard science.
But the sheer elegance of it, that specific size-distance thing, it does lead some people to wonder if maybe our understanding isn't quite complete, or if there are other principles involved we haven't figured out yet.
And this is where it gets super interesting for me. If you rewind like thousands of years.
Think about ancient civilizations. Babylonians, the Chinese, the Maya. No telescopes, none of our modern tech.
Right, just naked eye observation.
But they were meticulously watching the sky. They kept these incredibly detailed records of eclipses, timing, how they looked, everything.
Phenomenal records, really.
How? How did they spot patterns, even predict these things with just their eyes?
Well, it comes down to incredible patience and really systematic observation over generations. They were completely tuned in to the cycles up there.
Okay.
They track the moon going around the Earth. That's about, 27 days?
Yeah, the lunar cycle.
And Earth going around the sun 365 days the year. But crucially, they noticed eclipses didn't happen every single month, every time the moon was new or full.
Right, because the orbits aren't perfectly flat together. There's that tilt.
Exactly. The moon's path around us is tilted by about 5 degrees compared to Earth's path around the sun.
Okay, so it's like two dinner plates, but one's tilted slightly relative to the other. That's a good way to picture it. So they won't always line up perfectly.
So what was the key then? How did they crack the prediction code?
It was those moments of intersection. They realized eclipses only happen when the moon is crossing the plane of Earth's orbit at the same time it's aligned with the sun.
Ah, the crossing points.
Exactly. We call them nodes now. Think of them as the specific windows in time and space where sun, earth, and moon can align for an eclipse.
Okay.
And these ancient sky watchers, just by watching and recording for centuries, they identified these nodes and the cycles connected to them, like the Babylonians figured out the Saros cycle.
The Saros cycle, right. I've heard of that.
Yeah, it's a period of about 18 years and 11 days. After one Saros cycle, a very similar eclipse tends to happen again.
Wow.
By recognizing these long patterns, they could forecast future eclipses with, honestly, pretty amazing accuracy. Scholars in India, the Islamic world, China, they all developed sophisticated ways to track these cycles.
It just blows my mind. Doing that without understanding gravity the way we do now, or orbital mechanics, just pure observation and pattern recognition.
It's truly a testament to human ingenuity and focus.
And, throughout history, these eclipses, whether they were predicted or totally unexpected, they were often seen as huge deals, like major omens.
Oh, absolutely. Linked to big events, kings dying, wars starting or ending, massive societal changes.
Is there a famous example of that?
Well, probably the most cited one is the solar eclipse back in 585 BC. Herodotus wrote about it.
Okay, what happened?
Apparently, two armies, the Medes and the Lydians, were in the middle of a really fierce battle. 5 years they'd been fighting, I think.
Wow.
And then, bam, total solar eclipse. Daylight just vanishes.
Whoa. Must have been terrifying.
Reports say both sides were so freaked out by the sudden darkness, they just stopped fighting, dropped their weapons.
Seriously, it stopped a war.
Led to a truce and eventually a peace treaty cemented by a marriage, believe it or not. It's like the universe itself just said, enough.
That is incredible, like cosmic intervention.
It's a dramatic example of how profoundly these events could be interpreted and how they could impact human affairs.
And even today, right, we have the science, we know exactly what's happening, but a total solar eclipse still feels different, important.
It does. There's still that sense of wonder, maybe even a little bit of primal fear.
People travel all over the world, spend tons of money just to stand in that shadow for a few minutes.
The Umberphiles, they call themselves. Shadow lovers.
And you hear those stories, right?
Yeah.
About animals acting weird, birds stop singing, crickets start chirping.
Yeah, there are many anecdotal reports.
Yeah.
Animals suddenly going quiet, maybe acting confused, thinking it's nighttime.
And the temperature drops noticeably, too. You can feel it.
You definitely can. It's a multi-sensory experience, not just visual. It's as if the whole local environment reacts.
It suggests maybe a deeper connection, doesn't it? Even if we understand it intellectually, our bodies, the world around us, still registers this interruption.
It certainly seems that way. It taps into something more fundamental than just our scientific knowledge, perhaps. A shared experience with the planet.
And then, okay, you get into the more out there ideas.
The fringe theories.
Yeah. Like, some people believe eclipses are moments when hidden things are revealed. Secret planets, Nibiru, that sort of thing.
Right, the idea that the darkness unveils something usually hidden by the sun's glare.
Or even that the moon itself isn't natural, that it's artificial, put there specifically to cause these perfect eclipses.
That's another persistent one you hear sometimes.
Now, obviously, we need to be clear, right? These aren't ideas supported by mainstream science.
Not at all. There's no scientific evidence for hidden planets being revealed during eclipses, or for the moon being artificial.
But it's interesting why these ideas pop up, isn't it?
I think it speaks to that human need for meaning, especially when faced with something so awe-inspiring and, again, seemingly improbable like a perfect solar eclipse.
So if the scientific explanation feels too simple, maybe, or not grand enough?
Perhaps. Or maybe it just doesn't satisfy that deeper sense of wonder, or the feeling that there must be a bigger reason for such a spectacle. People look for patterns, for purpose. Sometimes that leads down conspiracy paths.
Which really brings us back to the core question we started with. Are eclipses just amazing natural events, beautiful results of orbital mechanics that we happen to understand now?
The celestial mechanics view.
Or do they hint at something more? A bigger pattern, maybe a cosmic significance that we just don't fully get yet?
It's the philosophical leap, isn't it? When you stand there during totality or even just contemplate the event, it's hard not to feel small.
Definitely humbling.
Yeah, it puts our daily lives in perspective against this vast clockwork universe operating on scales we can barely imagine. It's this moment of precise alignment, gone in minutes.
Exactly. Most days we're wrapped up in our own stuff, right? Work, family, the news.
We idiot.
Yeah. An eclipse forces you, compels you to look up, to see something truly extraordinary, truly rare.
A shared cosmic event.
And in that moment, that awe, you can't help but wonder, why? Why this perfect alignment? Why are we the ones here now able to see it and even ponder it?
It pushes those deeper questions to the surface. Questions about existence, purpose, our place in it all.
So maybe that's the thought to leave you, the listener, with. Next time there's an eclipse, even a partial one, try to experience it beyond just the science facts we've talked about.
Think about the history, the millennia of human observation and wonder.
Consider the sheer, improbability of that perfect fit we discussed, the cosmic ballet.
Feel that connection maybe to the generations before us who looked up at the same sky with awe and perhaps a bit of fear.
And maybe, just maybe, in those few minutes of shifting light and shadow, the universe is kind of nudging us.
Prompting us to think bigger.
Yeah, to consider these deeper questions about who we are and how we fit into this incredible cosmos. Questions science is always working on, sure, but that our sense of wonder keeps asking too.
It certainly encourages us to stay curious, doesn't it? To accept that maybe there are layers to reality, layers to understanding these events that we're still unfolding, that the awe itself is part of the message.